Welcome to Using Civil 3D to Prepare for Your Stormwater Analysis, presented by Kyle Groves. Kyle has been using Autodesk design products for over 7 years. His geological engineering degree, engineering and training certification, and desire to make design work more efficient led him to spend the last 4 years as a CAD management consultant with ATG USA. ATG USA is an AEC software and hardware vendor and has many services to offer for infrastructure, building, MEP, structural, and other AEC clients. Today, Kyle wants to tell you how you can make your stormwater modeling process easier by leveraging the data that already lives within your Civil 3D model. I'll be assisting with Q&A moderation and have just a couple of housekeeping notes before we get started. First, a big shout out to all of our sponsors for helping make this virtual workshop happen. Thank you. An evaluation link will be provided at the end of this session, as well as a larger email at the end of the day. Please complete it to help improve our event. Evaluation completion is also necessary to qualify for PDHs. Now let's start today's session.
All right, good afternoon, everybody. Welcome to today's course. Today we'll be talking about using Civil 3D to prepare for your stormwater analysis. My name is Kyle Groves. I am an EIT and recently became a senior CAD administrator with Bolton & Mink. My email's down below, but it's kyle.groves@bolton-mink.com. And a little bit more about myself. So I've got a Bachelor's of Science in Geological Engineering and a geology degree from UW-Madison. Go Badgers. After school, I got 3 years worth of design experience in the environmental field as well as some civil site design. And then for the last 4 years, I've been a CAD management consultant for an Autodesk reseller, ATG USA, based out of Little Rock, Arkansas, though I was working with their Minneapolis office. And very recently, I joined the CAD management team at Bolton & Mink. I'm living in St. Paul, Minnesota these days, and I enjoy long bike rides on the beach at sunset, as well as a number of other different things. But I've got some product expertise in AutoCAD in Civil 3D, storm and sanitary analysis, as well as InfraWorks. Also, I do have my EIT, so I've definitely been driven a lot by the passion of not just figuring out how Civil 3D and such can be used for plan production, but also to help our design processes move faster. And ultimately, that's what we're rooted in for today's presentation. So what we're going to talk about today, just review our learning objectives. Number one, we're going to gain insight into the tools in Civil 3D that work with stormwater analysis. Number two, we're going to review the purpose-built stormwater data that's already built inside your Civil 3D model. Lastly, we'll learn how to extract that data to use with a variety of design softwares and technologies. Now, don't read this, but if you're watching this later and you'd like to read the full course description, here it is. For now, we'll keep moving. As far as today's agenda, so the first thing that we're going to do is we'll run a brief overview of stormwater design. Yes, this is a complicated field of study. There are entire conferences for this. We'll just standardize some vocabulary and review our basic goals. We're not getting into any sort of calculation methods or any of that stuff today. Once we're done with that, we'll go over what we need to know for manipulating surfaces inside Civil 3D. Talk about what we need to know for working with catchments and our flow paths, and then I'll do a workflow demonstration where we'll go in, we'll look at a site, and start playing around with this stuff to get a drainage exhibit put together. So, with that, stormwater design process. First off, our general process is going to look something like this. We need to understand the existing conditions. What's our cover, how much rain, how much outfall. Then we need to make sure that our proposed conditions are at least not any worse than they were before. Probably should make them better, and depends on your region. But after we've got those two situations kind of broadly outlined, then we need to start doing some calculations, which says, okay, this is my area, these are my runoff conditions, and my cover conditions, soil types, all that jazz. And we've got to do a lot of manual transcription of data between platforms. Now, the other big thing about this class is we are not talking about what you're going to do with this data, how you're going to calculate it. If you're using a spreadsheet for rational method or other stuff, that's fine. If you're using HydroCAD, some sort of swim modeling platform, maybe HeckHMS, even Autodesk SSA, Storm and Sanitary Analysis, we're all getting you to that starting line today. We're not going past that, but that's what we're working on. With that data, though, we got to get it out of our Civil 3D model. What is the area of that particular catchment? How much of that is soil type C? And then we got to manually type it into whatever our other design platform is. After we go through and figure that all out, we got to iterate. And then we got to bring it back into Civil 3D again. Maybe it's our pipe network data. Maybe we're just sizing up a channel with feature lines. But Stormwater is a very iterative process, and any opportunity that we can use to skip the transcription of data to increase our organization, then we're going to want to take that every step of the way. So the question I have for you is, are you using your design software effectively right now? There is a wide range of age groups and user experience levels for people who are doing these sorts of calculations. Sometimes it's one or two people at a shop, and that's all they do. Other people, will run through this as part of their project-wide checklist of design calcs. Either way, our software that we probably already have access to, considering that we're at this conference, is going to be a Civil 3D surface, a Civil 3D catchment object, and Civil 3D annotation. We're talking label styles. So, are you using your design software effectively? Well, by the end of this presentation, we'll have a pretty good answer to that question. So starting up, let's talk about how our Civil 3D surfaces come into play. And basically, our surfaces already know what's up. They know where the high points are. They know where the low points are. So our surface, because of all these little tin triangles, triangulated irregular network, you have a bunch of XYZ points connected by straight lines. Your contours are outputs. So because of all of this, our surface has definitions for high points and for low points where water can't cross. And this information is going to save us a whole lot of time from reading contours and from just doing all that manual grunt work of delineating your watersheds, your catch basins. All of those terms, I just mean as a single area where water doesn't leave. Civil 3D might call that a catchment object. Storm and Sanitary Analysis might call that a sub-basin. Other places, other software have various different names for it. I'm using those interchangeably as a collection point for water. So once our surface knows this information, we need to extract it from that surface. That's where the surface analysis tools help us visualize that big picture. Number one is going to be our watersheds. Number two is going to be our slope arrows. So what direction is a particular part of our surface sloping? Next, we've got our water drop tool, and that's going to help us identify our critical flow path. So that comes into play for our time of concentration calculations, which Civil 3D will do for us as long as we don't mind using the TR55 methods. And lastly, the biggest thing about this for our surfaces and Civil 3D in general is computers are dumb. They're inflexible. They only have the logic that was programmed into them. However, they're very fast. So as long as we can guide this in the right direction and use a little bit of our engineering judgment to manipulate not manipulate so much as massage the results and make them more appropriate for our calculations and our level of detail, that's what we're going for. So we're going to use the computers to get the bulk of that information, then we'll do some cleanup and move it on for our purposes. For those purposes, once we've got all of those depressional areas figured out, now it's time to work with the Civil 3D catchment tool and our flow path tools. So our catchment objects have a couple of different things about them. So number one, they get to capture the area and a runoff coefficient for a particular location within our model. So that's going to be a really nice summary tool that we can put together on a drainage exhibit or pass along to our modeling software. There are also dynamic Civil 3D objects. So as your model changes, maybe your proposed conditions get some different elevations in them, and you got to rearrange stuff, it might be a touch unfortunate to have to click and drag those different vertices around, but you do have the option. However, catchment objects don't have data shortcuts, so we're really going to want to use these either in our utility drawings that host our pipe network data, or we'll want to put this in a separate drawing where we're going to data reference in all of that information, and then we'll have those live in there. Catchments are also the parent object of our flow path object. So you can't define a flow path unless you have a closed area and that polyline defined. So a flow path is what Civil 3D is going to do to help us come up with our time of concentration calculation. So we're going to edit those inside Panorama. We are going to also have the ability to define up to 3 segments of each flow type. So again, I mentioned this is TR55, so that would be our sheet flow, our shallow concentrated flow, and our channel flow. We get up to 9 different groupings of those. Now, one other thing to note about these is that we get good labels for our plan view. However, there is no table option natively. So with that, let's talk about the actual workflow. How are we going to string this together? Well, number one is we're going to prepare our key data using the surfaces and our engineering judgment. Then we'll create catchment objects and define our flow paths from step 1. Lastly, we'll refine our drainage exhibit for things like labeling, organization, make sure that the labels aren't going to run on top of each other, get all your plotting settings done, etc. But more specifically, for those surfaces, our first step is going to be to create a composite surface as a single reference for all of that topo data. Even though we're not designing everywhere inside of our site, or even for the stuff off of our site, that topo information still contributes, and we want to be able to have one single reference to say, hey, here's my flow path. It starts off-site, it comes into my area, but I can't assign more than one surface for all of that. So we want that composite surface. Then we're going to go through the process of delineating our watersheds and our catchments, mostly through the surface analysis tools of watershed and slope arrows, as well as the water drop tool, which is on an analyze ribbon, but doesn't fit the analysis definition as far as our surface properties are concerned. And then once we have all of those displaying for us and we're happy with them, we can extract them from our surface and do that manual cleanup that I was talking about. Now, working with catchments, there are options for doing this automatically. However, I wouldn't have had you go through all of those steps in step 1 if I thought that they were worth it. So ultimately, the best result that we're going to be happiest with is one that we have a heavy hand in creating. That's why we're going to use from object for creating these catchments. We'll define the flow paths using our water drops that we used earlier. You can always clean those up too. And then lastly, we're going to edit our flow paths to make sure that our resultant time of concentration is valid and makes sense. And while we won't be actually exporting it today, that's a big part of using storm and sanitary analysis or the other Autodesk tools for your stormwater design, is that we don't have to transcribe all of that. But 1, 2, 3, let's hop inside the software and see how this is going to work. All right, so here we are inside of our model. We're looking at a urban site reconstruct. This has since been put together, but we're looking at an area, American Boulevard, east and west, and 34th Avenue, north and south in Bloomington, Minnesota. The airport's just a little bit up to the north, past all that. So we've come in here, we've done a little bit of proposed design. We've got this corridor running through here and our existing surface. So the first thing that we need to do is we need to give ourselves a common data reference to work with so that when our water flows over our existing conditions into one of these ditches, we can still track all of that with a single reference. So in order to do this, we're going to come over to our prospector, we're going to go to our surfaces to create, and we're going to call this one composite. I'm not too picky on what you do call that, just make sure that you have a convention in place and that you follow that convention. Some people there's a lot of different things that you can call it. Just denote that it's the single reference dump all for everything. I'm also going to set mine to a 1 in 5 display style. So with this, I now have my composite surface showing up in Prospector, and I can go into my definitions, and here's the big deal, is we're going to go down to our edits, and we're going to run this command called paste surface. So what paste surface allows us to do is combine surfaces into a single data reference. So I'll start out with my one surface, and then I'll come back in and I will paste in the other, which is going to look pretty good. But if I check my selection cycling, I've actually got my existing contours showing up where my proposed was. Well, that's because this has to do with our surface build order definition. If you go back and watch that again slowly, you'll notice that I actually put my proposed surface in first. So in this surface properties definition tab, the top thing was the first thing to happen, the bottom is the last thing. So really what I wanted to do here is I want my existing to come in first, and then I wanted my FG information to override on top of that. Once that's in play, now I can see that I'm following my existing contours outside of my roadway, and I'm following my proposed contours inside the roadway with those green and salmon colors. So now I can go ahead and I'll just disable the other two displays to no display. And let's start working with this. So I've done my little paste surface thing. Now it's time to run some surface analyses. So with that, I'm going to pop over to my settings real quick and just show you some of the different styles that I have in play. I've got my contours, but then I've got two other ones in here. I've got contours and triangles, which in my display tab is pretty straightforward. I have all of my contours, I've got my triangles, and that's going to happen. But I also have these things called slopes arrows turned on. If I change my surface to this slopes arrows, this is going to be the first surface analysis that I don't even actually have to analyze for. But as soon as I do, since I have my triangles turned on, that's what all these gray lines are, every single triangle inside my surface now has an arrow associated with it that's saying what direction is down for that triangle. So right now these colors don't mean anything because I haven't run that analysis, but I could run the analysis on my surface and actually go through and define what that band range is going to be. So we always do our surface analysis through the Properties tab, Properties dialog in the Analysis tab. And I do have a slope arrows. If I just run through that, it's going to give me bins. I can color code them. This isn't the analysis that I want to spend a ton of time on today. That one is actually our watersheds analysis. So these all have a lot of really great little applications. Google up your favorite blog or YouTube videos on these. We've got lots of different things on the internet to go check from, including over at atgusa.com or YouTube or ATG's YouTube page. So, but this watershed analysis, this is the thing that we really care about today. And unlike our typical ones, we're actually not choosing the number of bins, but how big we want these depressions to be, or rather how fine we want them to be. I'm actually just going to say minimum depth of 1/4 foot, and then I am going to drop that down. Now this is going to go through and it's going to find all of our different little boundary segments. Honestly, I'm a really big fan of the Civil 3D help. I am going to refer you to the help to get specific information about what is going on with these analyses, as well as some of the other bits of information about what a depression is versus a flat area. The multi-drains do get pretty interesting, but again, I will refer you to the help because it's going to explain it much more clearly in much less time than I will. But our main types of watersheds that come out here, we've got boundary points and segments. Basically, this means a watershed that touches the edge of the surface. So we really don't have complete information over all of that. And hopefully our survey is going to be beyond our property boundary anyway, or at least get us close. So I'm going to actually disable those. I don't really care about them. I definitely want my depressions. Flat areas are going to be somewhat useful, and then these multi-drains are going to give me an opportunity to do a little bit of that engineering judgment. So I was able to disable about 30 of these, and I've still got another 45 left after that. So I'm going to say OK, and that's actually going to go through and it's going to analyze my surface. However, I can't see any of those watersheds showing up because my surface style doesn't have those turned on. If I were to go to edit my surface style, I'll see that I actually don't have my watersheds turned on. I have my slopes arrows turned on, but everything under minor contour, these are all your different analysis types that you can see within your surface properties dialog. So if you're going to run that analysis and you want to see it in your plan view, then you better have a surface style set up to handle that. Luckily, I do. Mine's called the watersheds style. And if I come back now, I can see I've got these green lines kind of traversing throughout my project. And as long as I follow them, I can see that my surface arrows are roughly pointing themselves in a direction that would keep them from overlapping on top of each other. So for example, if I come over to this area, it might be a bit tough to see, but there's actually a watershed dividing line right here, and my arrows are headed south below it and north-ish above it. So again, I don't have those slopes analysis defined. These colors don't mean anything, but they're always going to be pointing downhill. Now I've got some other areas of interest going on here with all of that. Oh, my RDP is just wigging out for me a second. I've got this red area over here, and I've got this yellow area up here in a couple of different places. Those are my multi-drain areas. And I can adjust all of that if I select my surface in my surface style. I'm not going to go too deep into the display management and the style management for all of this, but suffice it to say, you can rig up a color for these different boundary areas. You can have them get hatched, yes or no. You can choose that pattern. You can choose whether or not you want the markers to show up. It's all in here under your watersheds tab. But really, that's as far as I want to go with this right now, because this is all the automatic output from the surface. I want to start understanding where my water is going to actually fall. So my model thinks, let me just change this real quick to turn off my triangles, but do keep the arrows. Should make it a little cleaner. So right now, CAD thinks that I've got my own watershed area right over in this range. Well, how can I prove that? How can I kind of start figuring out, is this really a high point or not? Well, that's where our water drop tool comes in really effectively. So if you come to your Analyze tab by itself, the ground data has this flow path water drop collection. It's also where we're going to create our catchments in a little bit. Or if you have your surface selected, you'll see the water drop show up in the contextual ribbon under the Analyze panel for that. Either way, it's going to ask you, okay, we're going to create a bunch of these objects. They're going to go on a layer. They can be a 2D or a 3D polyline, and we can choose markers yes or no. Now I'm going to recommend that you have at least 2 layers in your template dedicated to this. You're going to have 1 layer for your actual final draft flow path. Then you're going to have a second layer. I just adapted one of the out-of-the-box NCS templates for this, F-spot. I don't even know what that is actually supposed to mean. I'm just using it because it's different. But you're going to create these all on a layer that is not your final draft, because you're going to create a bunch of these, and eventually you're going to want to turn them off or delete them. So as soon as I click anywhere on my surface, I can see that my water is going to fall down. I'm starting over here on the right. They're ending up on the left. They're starting to follow these arrows. When I get to my existing curb, I can see them actually drop off and just start flowing to the north. So this is useful for me to do a lot of that high point stuff. And if I cross myself over and I get closer to one of those lines where Civil 3D thought I was going to have a boundary, if I snap to one of those points, it's actually going to create 2 of these polylines for me. I'll escape out of water drop and see here's one polyline going off to the northeast and another going off to the northwest. So it'll even be smart enough to split those for you. And eventually, you're going to end up with a water drop. Let me keep going and just kind of backing myself up. You're going to end up with a good idea of where that terminal end of your flow path is, and you'll sneak it back up into that top corner, and then you can finally just select that one and then you'll move it onto the layer, which is your quote-unquote final draft layer. So I'm going to move mine to my catchment flow path. It's going to turn cyan. Then I can simply select select similar of those drafty ones, and I can delete those out. Now, again, this is the software doing its business. If I turn back on my contours, I'm still responsible, and I still would be benefited from coming through here and running my own right angle check to make sure that this water drop is always perpendicular to those contours. And in this case, it's done a pretty good job. However, depending on the data quality of your surface, how tightly you collected your existing conditions, what sort of supplementing factors you used for your proposed conditions, you might want to change some things. Well, no worries, this is a polyline. And yes, I did choose the 2D intentionally because we got that composite surface where we can get our surface data from for our elevations. But this is a polyline. You can come through and you can change where you want these vertices to be. You can add vertices. So this is here to get you started, and you can still manipulate this later on to your heart's content. So we've talked about watershed analyses. We've talked about creating flow paths. Now I want to extract, or I want to make those watershed polylines that our surface gave us, I want to make these useful to me now. So the next thing that we're going to do is we are going to extract data out of our Civil 3D surface. So big thing here is you always have to have the data you want to extract enabled in your display tab for your surface style. So notice that while I have the watersheds with no contours or no triangles, I'm not going to see those in my extraction menu. So I'll select my surface, I'll come up to my contextual ribbon, surface tools, extract objects. And again, we've got our border, our arrows, and our watersheds because those were the ones that were selected, or rather engaged by the display style. I'll deselect. I only want to keep my watersheds on. I will take all of them. And now I can say OK. And if I were to change my surface to border only or no display, now I can still see these polylines, and they're built up as 3D polylines, which, it's not the end of the world. I'll just come down, isolate. I don't like 3D polylines. Those are AutoCAD objects, and we're living in a Civil 3D world. So most of the time, I come down and I convert 3D to 2D and drop them all to a 0 elevation through my properties palette. Note that it was picking up some of those hashes. So you're going to go through here, you are going to figure out, hey, this multi-drain, where was that supposed to go? And you'll find a home for one of these other areas. I do want to point out one command which is going to be really useful for this. Let me unisolate my layers and kind of turn my surface back on just for display purposes. Not border only, I want the 1 of 5 background. So what's happening over here from station roughly 300 to station 500 is we're on a hill. So all of this stuff is going up, and all of this water is flowing northeast-ish away from my surface. And it's even got like a cutoff here because the corridor surface got a little wiggly. But ultimately, where's this water going? Is this water really stopping in this watershed, or is it all coming through this whole northeast corner of my site and then eventually ending up down here in this ditch? Well, the latter is true. So I don't really need both of these catchment areas or both of these watersheds. What I want is to combine them. We do have a command for that. I'll go ahead and write this down. It's called line work shrink wrap. I don't know where it is in the ribbon, but what it allows you to do is select multiple polylines. I did a crossing, so it got both this little one and the bigger one on the outside. And now it's created a polyline that is basically the B poly for multiple different polyline regions. So then I can simply come back here, grab those two component ones, delete it, and now I'm left with the one single watershed. Now the other ones were green because of how my surface style was put together. My layer is actually this soft blue. I think that's 150. So that's why the colors are a bit different. But this is the process that you're going to go through. You're going to create your water drops, you're going to figure out where your critical flow path is, and then you're going to determine just how big or how fine a level of detail you want for the watersheds throughout your site. At this point, I'm going to kind of play a little Food Network magic, and we will move forward in time to the point where we've gone through, we have created all of these various boundaries, we've created all of our various flow paths. Don't worry, I left us a few so that we could still go through and create on them. All right. Sorry, I got a little lost here. So I went through, I've got catchments going for most of my site, basically clockwise from like 11 o'clock through here. My two outstanding ones are going to be the east and west half of my road in the north half of the site. So as I zoom in here, I can see I've got a couple of polylines that don't have that little yellow marker. These are my water drops that I had created previously, and I've also got that kind of light blue color polyline representing the outline of my catchment area. So we extracted our polylines from our watersheds from our surface. We played around with our water drops. Now it's time to actually create catchment objects. So we're going to find catchments in our Prospector tab right under sites and above our pipe networks. Now, this is a Civil 3D object. However, note that we don't have it down here in our data shortcuts area. So this is going to be an object that we are stuck with in only one drawing. For a smaller site, perhaps consider putting that in with your utility base file, or also consider doing it as a completely separate file where you're data referencing in all of your Civil 3D information and only using this drawing to create your catchments and any other hydrology specific info. If we go to our Analyze tab, this is where I like to do most of my manipulation for my flow paths and my catchments, because in the ground data on the left, we've got our catchment group. We'll want to create one catchment group to at least, or we want to categorize our existing conditions and our proposed conditions, and we want to keep those separate. Additionally, if you're planning on kicking this data dynamically into other platforms, it is strongly recommended that every unique outfall has its own Civil 3D pipe network, and by extension, its own Civil 3D catchment. In this case, for demonstration purposes, I'm keeping it very simple. I'm only creating my proposed catchment group for everything. Now with our catchments, we do have a from surface from object command. I've got a handout in a bit of an unconventional way, but I do have a handout and it goes through why we don't like that. For now, suffice to say that we created all of those manual polylines and water drops for a reason. So we are going to create a catchment from object. Once we do this, it's going to ask us for that boundary. I'm going to come in here and I will do the west half, the left half of my road first, and then it's going to ask me if I want to add a polyline as a flow path. And if so, make sure that I click on the uphill end. So I'm going to do that. It's kind of like choosing an alignment from object. And now it's going to ask me for my catchment name. This actually, we're going to skip and we're going to go to look at our reference pipe network structure. Now this is if you're trying to dynamically kick this data around, but we have a green pick cube. I don't expect you or myself even to remember that information. We're going to go to the north and we're going to go to our terminal structure, which is this channel pipe, that channel catchment right down there. And the reason why is because whenever we're pairing up a structure with a catchment, we want that to be in the name of our catchment. So rather than do next counter, I'm going to paste in catchment st parentheses 11, and that's why. If we want to dynamically move this data to at least storm and sanitary or hydroflow storm sewers, we have to have a catchment associated with a pipe structure every single time. No catchment, no structure means we're not going to get our area data for a particular subbasin or watershed, whatever word you want to use. So that's really important if we plan on moving this data around. If you're in a situation where you do have actual storm data, that's going to make a lot of sense. However, it's it is going to feel kind of weird if you're like in your existing conditions for a green field, or if you're trying to manipulate and track open earth channels. You're not actually going to have a pipe network there, but you do need this smart data if you want to use the smart data transfer, if that makes sense. So our catchment name and our tagging with a pipe network structure. Back to the dialog here. Exclusionary, this is mostly just saying, hey, we've been thorough about this. This area is only going to drain here. We don't have overlaps. We're not trying to delineate between, or rather we've already delineated whatever information we need, whether that's just drainage area or if we've even gone to the level of soil type. And now on the bottom half, we do have two tabs. There's the catchment and there's the flow path. So the catchment style, this is generic Civil 3D stuff, just what line work, what layer your flow path and your boundary are going to be on. And then labels. I'm not going to get too into this. I'll refer you to the handout. Suffice it to say that in our contents, we have a variety of different pieces of information available for our labels, mostly related to area and time of concentration, as well as our pipe network. But if you can field it, you can put it in there. Same thing for our flow segment. Now, we do have a runoff coefficient. We can go into the template and change this later, but Civil 3D mostly assumes that you're trying to use rational method. It's quick, it's easy, it's conservative. In this case, you can leave it at 0.5, or you can change it now. I'm going to leave it because I don't really work with rational that much. I stick mostly with TR55. So I'd have to have a curve number and all that jazz. For our flow path, this is going to ask us what is our time of concentration method. It's either TR55, where we get to build that, or user defined is we're strictly just typing that in. With a site this small, I could probably go straight to my 5-minute minimum and be kind of conservative, or yeah, I'd have to calculate it with the TR55. Big thing here for our flow path slopes. When we created those water drops, we did have an option to create it as a 3D polyline. We chose not to because we wanted to go from our surface. We can assign this now, or as I'll show you, we can assign it later once we get into the flow path dialog. And when I OK through the catchment, it's actually going to keep me in this command because it assumes that I want to just go through and start grinding out catchment areas, which I'll go ahead and I'll take the next one. Selection cycling makes this very easy to go choose that polyline. And now for demonstration purposes, I'm going to skip adding the flow path at this point in time. I am going to use my green pick cube to pair this with my downstream structure. And I'll copy that name and I'll paste it in to the catchment name. And the rest of this can all stay as is. And I am done creating catchments, so I can enter or escape out of that command. And now we can see what these objects look like. So if I select my catchment, that one's kind of cluttered, so I'll go grab a different one. We'll grab this one. I can grab my catchment object, is automatically going to create a label. This label will find itself in the centroid of a rectangular hitbox for that particular area. And then if you have a flow label, that flow label is going to be diamond grip anchored to the actual flow path. And then it'll have those various segments on it. So just a couple of kinks about that. So if you have like a U-shaped catchment area or some sort of non-regular shape that kind of wraps around stuff, you may need to play with your catchment area label settings, and you may need to actually disengage the leader on that. We go through and actually look at this. I can select catchment, and I could do a grip edit. And congratulations, that's my catchment just got bigger, my catchment just got smaller. I can edit that after the fact if I don't want to blow it out, create new line work. I can go through and manipulate the vertices that I already have. I think we get to add vertices too. Yes, we can add and remove them. So it's not a complete, it gives us options. We get to keep the data. If I select a catchment area though, I'm interested in the flow segments. I can create these now if I forgot to do so later, or if I go into a flow segment that already exists, I can edit that flow segment. Our contextual ribbon for catchments is very straightforward. We have labeling, we have our catchment properties, and then we have these flow paths. So I can create from an object, which I want to do, or from surface, which engage at your own risk. Note that you won't find the edit flow path in there. You either have to find that in the right-click menu, or you can do so from the prospector, if you want to go that way. And when we're editing our flow segments, we're going to get this panorama window that pops up where we can add segments, remove segments, tag a surface, and then that's going to give us our dynamic slopes. If I had forgotten to do this earlier, we can see that Catchment ST06 does not have a little file tree next to it, doesn't have a plus sign. No big deal. I can right-click on that or otherwise select it, and then I can say create flow path from object. It's going to be the same prompt as before. Choose something on the uphill end of that flow path. So I will. And now I can kind of go through and work that out. Because it's very crowded over there, I'll come back to this one because it's going to make a convenient example for editing these flow segments. So I've got 3 different types available to me. I have shallow concentrated flow, sheet flow, and channel flow. I know this is the Wiz conference. For demonstration purposes, I'm going to assume a 100-foot maximum sheet flow. And this is important because when I come through to edit or to create a flow segment, I'm going to see a sneaky interface that is going to lie to me. It's got my little laser level as if I was trying to pick an offset, an alignment, or a station and offset from a pathed feature, which is true. However, I don't want to type this value in. I want to just pick it in my drawing. So this is a question where you have to ask yourself, what is the value of a 100th or a 10th in my design? I'm going to prompt you to encourage you to say it's not that important. So zoom in as much as you need to and mouse around as much as you can to get that value close. When you're happy, simply drop a left click. You'll get a marker in your drawing for that segment, and then you'll get the new thing happening farther down the line. So sheet flow at 100 feet automatically transitions to shallow concentrated for the second bit. And then when I get to either a significant slope change, or in the case of a curb channel, I'm going to want to add in that third amount. The biggest thing that you want to keep in mind is that if you don't have a time filled out, like in this case, row number 1 has no time means invalid calculation. If you're trying to kick this into your other Autodesk software, you're going to get an error and you won't get your catchment and your watershed and your subbasin set up. So the thing that's missing here is a Manning's roughness from my sheet flow. I'll just say this is well manicured grass at 0.04, or rather 0.4. Don't laugh at me if I forgot a decimal. I'll go 0.04 because that's a little bit more in line with the time for 100 feet. And it's running at a, I already have my surface, but I'll confirm that that's the composite. It's running at a 0.8% slope, so that's really shallow. That is my logic check. And when I change my channel flow, again, I'm missing a little bit of data, so now I can see that the time is missing. For our shallow concentrated, the length is calculated for us automatically. We get to choose our surface type. We'll go with unpaved. And then I need a Manning's, I need a cross-section, and I need a wetted perimeter. Now, I don't really know or remember how to go through and do this wetted perimeter calc by hand. So I do have a handy dandy little cheat in the software. I said I wasn't going to do much external stuff, but I do want to point out our stage storage tool. Sorry, not stage storage, the Express calculator. We'll find this in our Analyze ribbon in the Design flyout. Express is kind of the lowest power of Autodesk's onboard included software for hydrologic and hydraulic design. You can come in and you can build a single element at a time using various parameters. So I want to come in here and build a channel. I want to build a roadway section, and I can fill out the parameters that I have from my model. Mostly that I have a slope of 0.9%. I'm doing a gutter. My roadway is at 2%. My gutter itself is at 6%. I have a 1 foot wide gutter, Minnesota B612. Sorry, Wisconsin, I know. My invert is somewhat arbitrary in this case. I'll just put it at 100. My Mannings, this is decent concrete, 0.013. And cube by depth, that looks great. Once I've got all my parameters in here, I can run it. Oh, hey. SW exceeds of 5. Comparative. Gutter width times. Oh, this is feet over feet. So that's 0.02 and 0.06 respectively. There we go. So once you have a valid cross section, it'll come in here, and then you can actually pick whatever depth you want, and it will spit all these values out for us. So our wetted perimeter and our area, these are the two values we're looking for in Civil 3D. So that's 23.51 on the wetted perimeter. Our cross-sectional area was 5.31. And our Mannings was 0.013 for concrete. So it's going to come in, it's going to populate that time of concentration. That is what we're looking for. If we're kicking this to Autodesk data, our Autodesk data is now going to pick this up because our catchment overall, if I go into my catchment properties, I've got two things that are figured out. My total time of concentration and each individual time of concentration is determined, and I would have to have a reference pipe network structure for this catchment, which I can do that through the pick cube. So with a structure, with a time of concentration, this data will kick over. And at this point, we've talked about everything. We've talked about creating catchments. We've talked about creating and editing flow paths, how to go through that channel calculator. And I guess I'll show off my plan exhibit right now. So I've got my bolt and meg border, and this isn't going to be perfect, but I have I've got boundaries representing my my actual catchment areas. I've got catchment names. I've got time of concentration labels that I can put together. I typically take the impression that labels are labels and styles are styles inside Civil 3D. So for more info on that, I'm going to direct y'all to my handout, which is a white paper that I put together somewhat recently at my previous firm, ATG USA. I've got a link for where you can go through and download this, but I will point out that I've got about 2 pages worth of CAD management notes where you can go and look at how to set up your surface styles for these analyses, and then some considerations you can use for your label styles and your object styles, including converting your rational runoff coefficient to a curve number if you're feeling so inclined. So with that, let's go ahead and wrap up. There's the handout. You're going to find that at atgusa.com/whitepapers. You'll be looking for the Autodesk Civil 3D Guide Stormwater Design Plus Analysis Setup. But as far as our actual stormwater stuff, we recalled that stormwater design is iterative. It's got a lot of inputs. And with that, we want to maximize our organization and our dynamic connections. We want to minimize the manual transcription of data, but if we do have to, we want it very easy to read off and very easy to keep track of when we're typing that around. Then we learned about Civil 3D surfaces and the fact that they have most of the information we need, and we just have to use our analysis tools correctly to identify, extract, and manipulate that information. Computers are dumb, but they're fast. And people are smart, but we're slow. So it's all about trying to find the balance between the efficiency of computing with the engineering judgment that we always have to apply to our projects. Lastly, we learned that Civil 3D catchments and flow paths make it easy for us to summarize different regions and get accurate time of concentration calculations. So, with that, folks, I want to thank you so very much for your time today, and I'll be sticking around here for a few minutes with questions. Again, my name is Kyle Groves. I'm an EIT, and I'm a Senior CAD Administrator at Bolton & Menk. My email here is kyle.groves@bolton-menk.com. Thank you so much for your time today.